Decision tree is a very great tool to analyze decisions under uncertainty. It is a tool that makes complicated situations extremely visual and easy to understand. A decision tree identifies two types of events: decisions and uncertainties. It uses squares to represent decisions and circles to represent uncertainties. But how do you tell whether an event is a decision or an uncertainty? Well, it's actually quite easy. An uncertainty means you cannot control the outcome. For example, flipping a coin is an uncertainty with two possible outcomes. A decision, on the other hand, means there's a choice to make. For example, choosing between flipping a coin or not is a decision. So you can decide the outcome in a decision. So whether you can control the outcome or not is the key distinction between a decision and an uncertainty. Let's use the Thompson Lumber Company case as an example. This company considers to introduce a new product. If it introduces the product, it needs to build a plant to produce it. It can either make a large plant or a small plant, or not to do anything, meaning not introducing the product at all. However, the company needs to build the plant before knowing whether the product is popular or not. The company believes that the market can be favorable, meaning the product is popular, or unfavorable, meaning the product is not popular. The company believes that the chance of each market outcome is both 50%. This table summarizes the company's net present value from the investment. For example, if it builds a large plant and then the market turns out favorable, then the net present value for the investment will be $200,000. Now let's build a decision tree for this example. The key is to build the tree from left to right following the sequence of events. The events we're interested in are decisions and uncertainties. The sequence of events is the sequence in which events unfold. In other words, all we need to do is to think about what's next. If you recall the story I told you, you will notice that the first event the company encounters is to decide on the type of plane to build. That means the first event is a decision. So I'm going to draw a square to represent this decision. This decision has three options: building a large plane, a small plane, or doing nothing. So I'm going to draw three branches out of this square to represent these three options. First, a large plane. Second, a small plane. And third, a branch representing doing nothing. Once you have branches, you simply think about what is happening next for each branches. Let's start from the first branch, representing building a large plane. If it builds a large plane, what happens next? Well, we know once a plane is built, the company will realize whether the market is favorable or not. So, is this a decision or an uncertainty? Just let me remind you, a decision is the event that you can control or determine the outcome. An uncertainty is an event that you cannot control the outcome. Here, whether the product is favorable or not is not something you can control. So it is an uncertainty. So I'm going to draw a circle following this branch to represent this uncertainty. Similar to the square representing the previous decision, once you draw a circle, you need to use branches to represent possible outcomes. There are two possible outcomes because the market can either be favorable or unfavorable. So I draw two branches out of this circle to represent these two outcomes. Whenever you draw branches for uncertainties, like in here, you also need to mark at each branch the probabilities of each possible outcome. Since I know the chance of having a favorable or unfavorable market is equally likely, which is at 50% chance, so I'm going to write 0.5 here and 0.5 here. Just remember, you don't need to do this for the square. As you see, we don't have probabilities here because these are decisions. There's no probabilities for decision because you choose what to do. Again, once I have branches, I need to think about what happens next. Here, after knowing the market is favorable, is there any following event? Well, the answer is no. So I know that's it. This is the end of this branch. Likewise, there's no following event after knowing the market is unfavorable. So this is the end of this branch. At the end of each branch, we need to mark the payoff. A payoff is simply the measure you use to make decisions. Here, we are making decisions to maximize the company's net present value. So the payoffs are simply the net present values. For the table over here, we know that if the company built a large plant and the market turns out to be favorable, which is here, we know the payoff is $200,000. So I'm going to mark $200,000 over here to represent this is a payoff if the company built a large plant and the market turns out to be favorable. Likewise, if it built a large plant and the market is unfavorable, from here, from this table, I know the payoff is negative $180,000. So I'm going to put that number over here. Now I'm going back to look at this branch. Similarly, if the company chooses to build a small plant, the next event is to realize whether the market is favorable or not. This is an uncertainty, so I'm going to draw a circle here. This circle has two possible outcomes, so I'm going to draw two branches out of it. One for favorable outcome, one for unfavorable outcome. This is an uncertainty, so don't forget to mark the probabilities for each possible outcome. There's no further event, so I'm going to just write the payoff for each outcome here. For favorable outcome with small plant, favorable outcome small plant, the payoff is $100,000 and it's minus $20,000 here, according to this table. Finally, if the company chooses not to do anything, there's no further event following this decision. So the payoff is simply going to be 0 because the payoff is 0 regardless of the market outcome. So there's no uncertainty, there's no circle over here. At this point, we have constructed a tree to represent this problem. This is just the first step. We use a tree to represent the problem, but in the next step, we need to analyze the problem. As you can see, we build this tree from left to right. In the next step, we're going to analyze this tree from right to left to find out what's the best decision for this company. To analyze a decision tree, we analyze the expected payoff of each node from right to left. First, let me label the nodes so we can easily identify them. Let me start from node 1. If the company ends up here, then it has 50% of chance ending up in a favorable market getting $200,000 or another 50% of chance ending up in an unfavorable market earning negative $180,000. So that means the expected payoff from this node going forward is simply the probability times the payoff plus the probability times the payoff. Okay, so it writes like here. Okay, so you carry out the calculation, you'll find that the expected payoff is going to be $10,000. I'm going to copy this $10,000 over here next to the node so that I know when the firm builds a large plant, then its expected profit going forward from here is going to be $10,000. In other words, this number, $10,000, summarizes the expected payoff going forward from here. Next, I can analyze the next node, okay, over here. Similarly, the probability going forward is a 50% chance being in a favorable market, earning this payoff, or another 50% chance in an unfavorable market, earning this payoff. So the expected payoff for node 2 is simply, again, probability times payoff plus probability times payoff, which is over here. It comes out $40,000. Again, I'm going to write this $40,000 next to this node so I know this is the payoff from this node onward. And now at this point, I know the expected payoff of these two nodes. I can move to the left to analyze the node on the left, which is a square. So now knowing building a small plane is the best decision, I'm going to give a little check mark on this branch just to notify myself that this is the best decision for this decision node. And also I'm going to copy the expected payoff from this branch, which is $40,000, over here next to this square. So I know the expected payoff from this decision is this number, and it comes from building a small plane. So at this point, we complete the analysis for this decision tree. We build the tree from left to right, and then we analyze it from right to left, knowing that the best decision for the firm is to build a small plane with this number of expected payoff, 0.